Okay, in the last class we have seen about the lexical conventions. Okay, in that lexical convention we have seen the 7 types of lexical conventions. Okay, today we'll see discuss about the data types. Okay, data types in the HDL. Data types in Verilog HDL. What are the data types? Okay, as we already seen, as you know that the data types. Okay, our Verilog HDL supports the C language and even the OOPS concepts also. The same data types are we are using, but in that different way. Okay, there are around 8 data types are there. In that, we first one will consider the value set. Value set is to give the 2 types are there. One is what the Verilog supports that there are 4 types of values and the strengths. Okay, there are 4 types of values and the strengths here. Okay, in the value set here we have the 0, 1, X and Z. 0 is for the logic 0, which indicates what the false condition. Which indicates what the false condition. Okay, 1, if I use the 1, there is a logic 1, there is what the logic 1, this is what the true condition, this is what the true conditions. Similarly, here also I have the X is there. X is what the unknown condition, unknown logic, either it may be 0 or 1. As you all know, already knew this in this 0 or 1, it means don't care condition. We are using the X is nothing but the don't care condition. And Z is what the high impedance, which is to be given, which is high impedance. Z is nothing but the high impedance. In such a state, that's nothing but the floating state. Either it may be 0 or 1, something. Okay, its X is also similarly, but it's the high impedance one. This is the high impedance. These are what the value set. Similarly, strengths also I have it. Around 8 strengths are there. Verilog supports the 4 types of value sets. And also here also have the 8 types of strengths are there. Okay, 8 types of strengths. Let me write the strengths here. Eight types of strengths. Either the strengths are nothing but it's a level. We are giving the level. Okay, levels to be what the 8 types of strengths are there. Strength level, type, and the degrees here. Okay, one is that the supply is there, string is there, and the pull, large, weak, medium, small one, and the high Z is there. These are what type of supply is what the driving type. This is what the driving type, and also we have the strength strongest. Okay, it's what the strongest one, and also string is also having the driving type. Okay, string is also what the driving type, and also pull is also what the driving type. And large is having the storage type. This is what the storage type. And the weak. Okay, this is weak is also what the driving type only. and also we have the others are what the medium and small are also storage type. High Z is what the high impedance value is. This is what the high is. The Z is nothing but the impedance, high impedance one. Okay, these are what the strength levels. We have the value set we have seen. There are 4 types of value sets. Similarly, here also I have the 8 strengths are there in value set. In the value set itself, we have around 4 are there. In the value set, we have the 8 strengths and the 4 value sets are there. One is what the 4 value sets we have seen. Similarly, strength level also we have the 8 types are there. These are the what type of the driving type or storage type. I will teach you this what are the driving type and storage type in the next class. Similarly, here we have the degree for this one. What is the degree? It will be increasing every time. Okay, from this 0 level to weak level to what the weak level to strongest level. It will be increasing as a increasing. It's a increasing one. Okay, this is what there are for. As I seen, these are the 8 types of strength level. Write down, copy it, this one. Okay, according the combination is there. Okay, we'll see if I take the 2 strength levels and the 2 value sets, what will be happening. Okay, we will see the combinations. We will have the combinations also. If I take the 2 signals of the unequal strengths, if I take the 2 signals of the equal strength, if I take the one strongest signal, another is the weakest signal, there is a combinations. How to make it a combination? Okay, if I take the two signals, okay, 2 signals of the what the 2 signals of strongest, okay, strongest. If I take the 2 signals of the strongest, which are the unequal signals, then there is a driver. Okay, there is a stronger signal will get. Okay, there is a stronger signal will get. Strongest means what we will get the stronger one. If I take the unequal one, ಈಗ ಯಾವುದೋ ಒಂದು ಅನ್ಇಕ್ವಲ್ ಇರ್ತದೆ, ಇದು ಹೈ ಇರ್ತದೆ ಸಿಗ್ನಲ್, ಇದು ಸಣ್ಣದಿರ್ತದೆ, ಸ್ಲೋಯೆಸ್ಟ್ ಇರ್ತದೆ. ದೇರ್ ಇಸ್ ಎ ಕ್ಯಾನ್ಸಲೇಷನ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಒನ್, ವಿ ಲೆಫ್ಟ್ ವಿತ್ ವಾಟ್ ದ ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ ಒನ್ ಓನ್ಲಿ. If I take the 2 signals equal, 2 signals which are having the same strength, then definitely the output of this 2 strength signals will be what the weakest only will get cancel. If I take the 2 signals of the strongest one which are unequal, then there is a possibility of the stronger signal will be prevailed. Stronger signal will be present. Okay, if I take the 2 signals of equal strength, ಇತ್ತಂತ ಎರಡು ಸಿಗ್ನಲ್ ಸೇಮ್ ಇದ್ರಾಗ ಏನಾಗುತ್ತೆ, ವಿಲ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ ಒನ್, ವಿಲ್ ಗೆಟ್ ವಾಟ್ ದ ಔಟ್ಪುಟ್ ಆಫ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಒನ್ ವಿಲ್ ಗೆಟ್ ದ ವಾಟ್ ದ ವೀಕರ್ ಸಿಗ್ನಲ್. Okay, this one we can set for the unequal or unconditioned unknown signal. Unknown is nothing but the x also. It may be what the 0 or 1. Definitely here the value signal is what here the 1 only. Here the value signal is what the 1 only. Definitely the 2 signals which are equal strength, then definitely will get the weaker signal. That's to be what the either 0 or 1. It's to be what the x condition. Okay, Take the next topic as the nets. What I am teaching here, data types. Data types are used as the variables or parameters. These are the used to send what the signals, okay, values here. In the digital design system, we have the nets and all. For example, here this is what the one digital system, okay. This is what our digital system having the four inputs and the one output. Okay, how many inputs are there? 4 inputs and the only one output. These are we call as what the inputs. This is what the output here. This is what the input. This is what the output. Then there is a connection between the one gate to another gate, one module to another module. We call those things are the nets. We call this what the nets, or we can say it's what the wire also. Connection between the two gates or two modules which are connecting together through what the physical things. These called as what the nets or wires. Net or wires are used to what the sending the signals, but the values storage elements which are what the like a flip flop, some other values as the storage elements, resistors which are used for the storage purpose. But these wires or nets are used to transmit the signal from the one logic gate to another gate. These are called as the physical wires, and even we can say it's for the nets also. We can it's for the nets also. Okay, nets. These are the connections between. Okay, take the next heading as the next nets. Okay, net only. Nets. Okay, nets are represent Mercury. Nets represent the connection between the hardware elements. 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 Next point, nets have values. Nets have values continuously driven. Continuously driven. Continuously driven. Continuously driven on them. On them. Continuously driven on them. Continuously driven on them. By the outputs of devices. By the outputs of devices. By the outputs of devices, they are connected. They are connected. Let's represent. Okay, let's represent what the there is a connection between the hardware elements. Okay, hardware components. We have the how many nets are there? 2 nets are there. What are those? N1 and the N2 is there. N1 and the N2 is there. Just to copy this figure. Copy this figure. Next, so can say it's what's the okay, these are called the nets. Just to copy. Okay, nets. Okay, usually as you already seen in the basic classes, the how to write a nets. As we declared these nets with the help of what the one keyword that we call the wire. Okay, whenever if you want to declare these nets, these called the wires. As I told you in the earlier classes, basic classes, these are connection between the gates to gates or model to model. These called as what the nets. But in the while writing the program HDL Verilog HDL programming, there we have to use the keyword that we can call as what the wire. There is we call it the wire. Okay, wire. Okay, okay. Take the here the if I have the wire. Okay, these are the I am going to write some program, small piece of code for this purpose for declaring the nets here. Let me have the wire. Wire. How many wires are there? N1 and N2. Okay, so that wires I cannot use the wires. Only wire you have to write the wire N1 comma N2. semicolon. And here we can say is what the wire is also having the some values over that. What type of values it is carrying here? Is it the digital binary value or something? What is the value here? So that I am declaring this one as the a equals to 1 bit of what is the value of this one is the 0. This is what the 0. This is carrying the value. This wire is carrying the value which is having the a equals to what the 1 bit. This is what the 1 bit. B is nothing but the bit, binary bit. Okay, this is having the what type of value? 0. If it is having the value 1, you should have to write the what here the 1 only. But I am saying using the why this having the this binary bit is having the value as the 0 here. Okay, next is what the wire to be what type of wire? This is what the wire a equals to what the value it is having now 0 itself. It is having the value here the what the 0. Here the value the 0. Wires are declared. Okay, nets are declared with the help of the keyword as the wire n1 and n2. Here the for example I am taking this is the wire. Okay, this is what the wire a equals to what the 1 only 1 bit. 1 bit, that's the having the carrying the 0 only. Wire a equals to what the 1 0 only. Okay, take the heading. Okay, that's the in the above figure. In the above figure, A, B, C, D are the inputs. In the above figure, A, B, C, D are the in the above figure. A, B, C, D are the inputs. In the above figure, A, B, C, D are the inputs. In the above figure, A, B, C, D are the inputs, and Y is the only one output. Y is the only one in output, comma N1 and N2 are represent the N1 and N2 represent the connection between the gates. Connection between the gates, and hence it is a net. Okay, net ಅಂತ ಬರೆದ್ಮೇಲೆ ಅದರ ಇದನ್ನ ಇದು ಹಾಕ್ರಿ ಸೆಮಿಕೋಲನ್. Okay, next point. Nets are declared with the keyword. Nets are declared with the keyword wire. Nets are declared with the keyword wire. Example, take this example as the wire N1 and N2 here. Wire in N1 and N2. In this one only, just to write the wire N1 and N2 semicolon, you can write the single line comment also in this. Okay, in between this one, here the N1 and N2 are the N1 and N2 are the two wires. N1 and N2 are the two nets, two wire nets and wires and wire and N1 and N2 semicolon. Okay, single line comment akri. Just to write here what the N1 and N2 are the two. N1 and N2 are two wires. Two wires in the for the circuit. Two wires for the okay. You are declaring here. These are the N1 and N2 are the two wires. Okay, in the N1 and 2 wires, and also wire equals to A. Wire A equals to what the 1 bit of 0. Wire A equals to what the 0 only. Okay, usually the nets are carrying the what the only default value is there. What is that value? Only single bit. It will not carry the multiple bit. You should remember. Okay, wires always carry what the one single bit of information. Okay, one single bit of information. This is what the default value. Okay, ಯಾವುದೇ ಒಂದು wire ಕೆ ಬರ್ತಿತ್ತಂದ್ರೆ if you are declaring, that will carry only what the single bit only. It's what the compulsory. And also which are declared with the help of unless they declared as the vectors. You ಒಂದು wire and declare ಮಾಡಿದ wire. If you can also declare the wire itself as the in the vectors also 3:1 0. This is what the vector condition is there. This is carrying this wire carrying what the up to the 0 to 3 means what the 4 bit of information. Default ಆಗಿ ಒಂದು ಸಿಂಗಲ್ ಬಿಟ್ ಕ್ಯಾರಿ ಮಾಡ್ತದೆ. ಈಗ ನಾನು ವೈರ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡಿದ ತಕ್ಷಣನೇ that will carry only what the single bit. If you want to send the multiple bit, okay, it's around the 4 bit, 8 bit or 16 bit ಈ ತರ ಡಿಕ್ಲೇರ್ ಸೆಂಡ್ ಮಾಡಬೇಕಾಗಿತ್ತು ಅಂತ ಇಟ್ಕೋರಿ. That time you need to send what in the form of what the vector form, okay, vector form. That's the what the vector. Okay, just to take the nets are 1 bit values. Nets are the 1 bit value by default. Nets are 1 bit values by default. Nets are 1 bit values by default, comma, unless they are declared as vectors. Unless they are declared as vectors. Unless they are declared as vectors. ನೀವು ವೆಕ್ಟರ್ ಆಗಿ ಡಿಫೈನ್ ಮಾಡಲಿಲ್ಲ ಅಂತ ಇಟ್ಕ, that will carry only what the single bit default ಆಗಿ. If you are declaring the wire itself having this vector form, it's what the 033 means what 4 bit of, it will carry the 4 bit of information. They can take the values. They can take the values. 4 values are there. They can take the values. 4 values. They can take the 4 values. 4 values. 0, 1, x, z. 0. They can have the values as 0, 1, x and z. The default value of a net is what? Always z. Next point, the default value of a net, the default value of a net is z. Either it is what the 0 or 1 unless declaring that itself, net itself, what wire itself has the 0 or 1 something or in the vector form. Default value ನೀವು ಏನು ಕೊಡದೇ ಇದ್ರೆ ಏನು ಮಾಡ್ತದೆ, impedance value ತೋರ್ತದೆ. ಅದು impedance value either it is what the 0 or 1. Okay, the default value of a net is what the z. Okay, next point, the nets get the output value. The nets get the output value of their drivers, The nets get the output value of their drivers, their THEIR, their drivers. Okay, if a net has no driver, comma, it gets the value z. It gets the value z. Okay. Next is what the registers. Registers are nothing but the key. These are what the storage elements. Okay. After performing some operations in the digital circuits, if you want to display, okay, if you want to send the values to the what the user or through what the registers itself, that register is different here. Whatever we are studied in the microcontroller, microprocessor, that is different. But the same concept is here also using for the storage element. Okay, as a storage element in order to store the intermediate values and also output of that particular digital design circuit. Okay, these registers are used for the storage elements. Okay, the storage element registers also defined with the one keyword that we call as the REG. Registers always declared with the help of the one of the keyword that we call as the REG. Registers can also have the 4 types of values. What is that? 0, 1, x and also z. 0, 1, x and also z. And also registers can also have the hold the value, okay, which will be until and unless if you want to make register 0. ಅಲ್ಲಿ ತನಕ ನೀವು ಎಲ್ಲಿ ತನಕ ಹೋಲ್ಡ್ ಮಾಡ್ಬೇಕಂತ ಇರ್ತಾರೆ ಅಲ್ಲಿ ತನಕ ಹೋಲ್ಡ್ ಮಾಡಿ ಇಟ್ಕೋತಾರೆ. ಬಟ್ ರಿಜಿಸ್ಟರ್ಸ್ ಡು ನಾಟ್ ನೀಡ್ ದ ಡ್ರೈವರ್ಸ್. ಹೆಂಗೆ ನಾವು ವ್ಯಾಲ್ಯೂಸ್ಗೆ ಸೆಂಡ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಡ್ರೈವರ್ಸ್ ಬೇಕಾಗ್ತದೆ. ವೈದರ್ ಇಟ್ಸ್ ವಾಟ್ ದ ಡ್ರೈವರ್ಸ್ ಆರ್ ಸ್ಟ್ರಾಂಗ್ ವೀಕ್ ಅಂತ ನಾವು ಕಳಿಸ್ಬೇಕಾಗ್ತಿರ್ತದೆ ಸಿಗ್ನಲ್ಸ್. ದಟ್ ಟೈಮ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಟು ಬಿ ವಾಟ್ ದಿ ಇಯರ್ ದ that is to be taking is as what the here we don't need what the drivers here ಅಲ್ಲಿ. ಬಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಸೆಂಡ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನೆಟ್ಟಲ್ಲಿ ಏನು ಬೇಕಾಗ್ತಿತ್ತು, ಡ್ರೈವರ್ಸ್ ಬೇಕಾಗ್ತಿತ್ತು. ಒಂದು ನೆಟ್ಟಲ್ಲಿ ಅಂದರೆ ವೈರ್ ಡಿಕ್ಲೇರ್ ಮಾಡಬೇಕಾದ್ರೆ ಆ ವೈರ್ಗೆ ಏನಾದ್ರು ವರ್ಕ್ ಆಗಬೇಕಾದ್ರೆ ಡ್ರೈವರ್ಸ್ ಬೇಕಾಗ್ತಿತ್ತು. ಬಟ್ ರೆಜಿಸ್ಟರ್ಸ್ ಡು ನಾಟ್ ನೀಡ್ ದ ಎನಿ ಡ್ರೈವರ್ಸ್ ಇಯರ್. ವಾಟ್ ದ ಎನಿ ಡ್ರೈವರ್ಸ್ ದೇ ಡು ನಾಟ್ ನೀಡ್ ಈವನ್ ವಾಟ್ ದ clock also. What the clock also. For the clock also we don't need here the, and also value registers can be changed anytime while simulation assigning the values. ಈ ಸಿಮ್ಯುಲೇಷನ್ ಮಾಡ್ತಿರ್ತೀಯ, ಔಟ್ಪುಟ್ ಕೊಡ್ತಿರ್ತೀಯ, ಸಿಮ್ಯುಲೇಟ್ ಮಾಡ್ತಿರ್ತೀರಿ, ಔಟ್ಪುಟ್ ತಗೊಂಡಾಗ ರಿಜಿಸ್ಟರ್ ಕ್ಯಾನ್ ಬಿ ಓವರ್ ರಿಟರ್ನ್. ಅದು ರೆಜಿಸ್ಟರ್ ಒಂದು ವ್ಯಾಲ್ಯೂ ಏನೋ ಫಸ್ಟ್ ಒಂದು ವ್ಯಾಲ್ಯೂ ಇಟ್ಕೊಂಡು ಕುಂತಿರ್ತದೆ, ಅದು ಯಾವುದೋ ಡಿಫಾಲ್ಟ್ ವ್ಯಾಲ್ಯೂ, ಅದರ್ ಇಟ್ ಇಸ್ ವಾಟ್ ಬಿ ಎನಿಥಿಂಗ್, ಓಕೆ 0 1 x z ದಟ್ ಕ್ಯಾನ್ ಬಿ ಓವರ್ ರಿಟರ್ನ್ ವೈಲ್ ಸಿಮ್ಯುಲೇಟಿಂಗ್. ನಾವು ಈಗ ಒಂದು ಯಾವುದೋ ಒಂದು ಸಿಗ್ನಲ್, ಅದು ಒಂದು ಡಿಜಿಟಲ್ ಸಿಸ್ಟಮ್ ಇರ್ತದೆ, ಈ ಡಿಜಿಟಲ್ ಸಿಸ್ಟಮ್ ಮೇಲೆ ಈ ಥರ ಪ್ರೋಗ್ರಾಮ್ ಬರಿತೀವಿ ನಾವು. ಇವಾಗ ಸಿಮ್ಯುಲೇಷನ್ ಔಟ್ಪುಟ್ ತೆಗಿಬೇಕಲ್ಲ, ಇನ್ಪುಟ್ಸ್ ಕೊಟ್ಟು ಔಟ್ಪುಟ್ ತೆಗಿಬೇಕಲ್ಲ, ದಟ್ ಟೈಮ್ ದ ರೆಜಿಸ್ಟರ್ ಕ್ಯಾನ್ ಬಿ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾನ್ ಬಿ ಓವರ್ ರಿಟರ್ನ್. ಓಕೆ, ಫಸ್ಟ್ ಡಿಫಾಲ್ಟ್ ವ್ಯಾಲ್ಯೂ 0 1 z ಏನೋ ಇಟ್ಕೊಂಡು ಕುಂತಿರ್ತದೆ, ಬಟ್ ದಟ್ ಕ್ಯಾನ್ ಬಿ ಓವರ್ ರಿಟರ್ನ್ while doing what the simulation also. Okay, default value of the register always what the x itself is that it's what the 0 or 1. Default value of the ಇದು ಯಾವುದು default value of wire ಏನಿತ್ತು, z ಇತ್ತು. default value of the wire ಏನಿತ್ತು, z ಇತ್ತು. but the default value of the register is what the x itself, x. Okay, register variable must be initialized always what the with the keyword as the always. Okay, we have seen in the last class. Let me explain in the board only. Okay, there are 6 concepts are there in the second module. Only important 6 concepts are there. ಈ 6 ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ 4 ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ನಾವು ಎಷ್ಟು 6 ಕ್ವಶನ್ದಾಗ 4 ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ. ಫಸ್ಟ್ ಥರ್ಡ್ ಮತ್ತು ಫೋರ್ತ್ ಕ್ವಶನ್ದಾಗ. ಥರ್ಡ್ ಕ್ವಶನ್ ಒಳಗೆ ಏನು ಬರ್ತಾ 3 ಕ್ವಶನ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅವ. ಅದೇ 3 ಕ್ವಶನ್ಸ್ ಬಿಟ್ಟರೆ ಏನೂ ಕೇಳಲ್ಲ. ಇರವೆ 6 ಕಾನ್ಸೆಪ್ಟ್ ಅವ ಇಲ್ಲಿರೋದು ಸೆಕೆಂಡ್ ಮಾಡ್ಯೂಲ್ನಾಗ ಇರೋದು. ಅದಕ್ಕಿಂತ ದೊಡ್ಡದೇನು ಚಾಪ್ಟರ್ ಇಲ್ಲ. ಯು ಕ್ಯಾನ್ ಸ್ಟಡಿ ಓಕೆ ಈಸಿಲಿ ಸ್ಕೋರ್ ದ ಮಾರ್ಕ್ಸ್ ಆಲ್ಸೋ. ಯಾ ಓಕೆ, ಲೆಟ್ ಮಿ ಹ್ಯಾವ್ ದ registers. Take the heading as the registers. Take the heading as the registers. Take the heading as the registers. RESI. ಓಕೆ, ಇದು ಬರೆದ್ರೆ ಏನಾಗುತ್ತಾ ರೆಜಿಸ್ಟರ್, ಇದು ಆಗುತ್ತಾ, ಇದು ರೆಜಿಸ್ಟರ್. REG register, REG ಯೂಸ್ ಮಾಡಿದ್ರೆ register as the storage element. You should remember this is what it will oppose the flow of current in the circuit, but it will helpful us to what the storage purpose. Okay, storage purpose. Just to take the heading as the registers. Here the registers are used for the storage purpose, storage elements. Registers can be retained the value, and registers can have the values as the 0 1 x and z also. Default value of the register is what the default value of the register is what the z. The keyword, the registers can be declared with the help of what the one of the keyword that we call is what the reg is what the one of the keyword we are using. Registers always changed anytime while simulation. The register can change the value as the anytime while doing what the register can change the its value while doing what the simulation. While doing the simulation. Okay, register do not need what the drivers here. Wires need what the drivers, but the here the registers do not need the what the wires also, what the drivers also. Okay, for example, if you want to work with the registers, okay, I already told you that while writing the programming in the behavioral model, registers always used in the for declaring what the output, while it's what the storage elements. The storage elements are nothing but the what the registers here. What is the necessity of writing the program here? Okay, what's the this is what the my default digital design system. Okay, this can be This is what the my default system. Okay. This is what the y equals to AB plus BC. Okay, AB plus of BC. For this one, I written the program in the register class and the basic classes. That one to be what the in the behavioral model. While writing the program in the behavioral model, how many models are there? How many models are there? There are three types of models are there. One is what the Oi, ಏನು ಮಾಡ್ತಿದ್ಯಾ? ಫ್ರೆಂಡ್ ಬಂದ ತಕ್ಷಣ ಕ್ಲಾಸ್ ಬಿಟ್ಬಿಡೋದಾ? ಫ್ರೆಂಡೇ ಇಂಪಾರ್ಟೆಂಟ್ ನಿಮಗೆ. Okay, that is nothing but there are four types of models, three types of are there. One is what the behavioral structural or structural data flow and what the behavioral word. While in the gate level, the gate level or structural model. Second one is what the data flow model. Third one is what the behavioral model. Switch level is not used usually. Switch level, all level design model now. There are four types are there. But in the behavioral model, while declaring the while writing the program in the behavioral model, we use what the register keyword. Okay, register keyword is used to declare what is that output one. Output. What is the output here? Y. Okay, the register keyword always works with what the always at the rate of always itself. At the rate of always. You should have to remember this one. Initial block. Initial, or else we can use even you can also use what the initial or else you can also use what the always. Okay, register keyword always used in the with the help of what the two types. One is what the initial keyword, another one is what the always. If you are using the register, thereafter you have to use what the initial keyword, or else you can also use what the always at the rate of always keyword. Okay, always keyword. Okay, let me write the with the help of the initial itself. Initial. Okay, initial always start with the begin. Okay, end. Okay, end module. You should remember this one. In between one initial. ನೀವು ಯಾವಾಗೇ ಒಂದು ವೇಳೆ ರಿಜಿಸ್ಟರ್ ಕೀವರ್ಡ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅಂತ ಇಟ್ಕೋರಿ, ದೇರ್ ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದ ಇನಿಷಿಯಲ್ ಬ್ಲಾಕ್ ಆರ್ ಎಲ್ಸ್ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದ at the rate of always. Okay, you should remember. Registers are also declared with the single signed variables also. Sometimes we will also use what the declaring what the signed variables also. Okay, take the heading as the registers. Registers represent the data storage elements. 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 Next point, registers retain value. Registers retain value until another value. Registers retain value until another value is replaced. Registers retain value until another value is placed onto them. Registers retain value until another value is placed onto them. They can take the values 0, 1, x, z. They can take the four values are there. 0, 1, x. 0 is for the false condition, 1 is for the true conditions. X is what the don't care, either it is what the 0 or 1. Z is what the impedance. Okay, Z is what the impedance. Okay, in Verilog registers, registers means in Verilog, registers means a variable. Registers mean a variable that can hold a value. This is also one type of variable. Okay, it will hold what the value here. It will hold the value as a storage elements. Okay, next point, storage. Registers do not need a driver. Registers do not need a driver. unlike a netನಾಗ ಏನು ಬೇಕಾಗಿತ್ತು, ಡ್ರೈವರ್ ಬೇಕಾಗ್ತಿತ್ತು. ಬಟ್ ಹಿಯರ್ ವಿ ಡೋಂಟ್ ನೀಡ್ ದ ಡ್ರೈವರ್ ಹಿಯರ್. ರೆಸಿಸ್ಟರ್ಸ್ ಡು ನಾಟ್ ನೀಡ್ ಡ್ರೈವರ್, unlike a net, they do not need clock. They do not need clock as hardware resistors. Next point. Values of resistors can be changed anytime. Values of resistors can be changed anytime. Values of resistors can be changed anytime. In a simulation, by assigning a new value to the resistor. Next point. Resistors are declared with keyword. Resistors are declared by keyword REG. By keyword resistors. Okay, small letter irbeku, big letter togobardadu. Always small letter. Keywords always declared with the small letters, you should remember. Okay, next point. The default value for a reg for a reg data type is X. Default value for a reg data type is X. X is nothing but, don't care, either it is 0 or 1. Next, reg variable must be initialized within the initial. Reg variable must be initialized within initial or always. Initial or always statement. Initial statement ಅಥವಾ always statement ಒಳಗಡೆನೆ ನಾವು register keyword ಯೂಸ್ ಮಾಡಬೇಕು. Okay, take that example. Here the resistors. Okay, this is what the declaring of the reset here. Okay, in this we have to begin. We are writing the code. Okay, this is what the reset purpose. Reset andre 1 agbodu atha 0 agbodu. Reset anta na use madnu anta, instead of using the clock, if I use the reset ಏನು ಮಾಡ್ತದೆ, 0 ಇದ್ದು 1 ಮಾಡ್ತದೆ, 1 ಇದ್ದು 0 ಮಾಡ್ತದೆ. For resistors reset, initially in this initial and end block, within this one we are defining the initial block. In the initial block we are defining the begin and end. In between this one, reset 1. Okay, 1 bit of information, that is what the 1. After the 100 seconds, after the 100 milliseconds, it has to be resetted as the 0. It is to be resetted as the 0 with the 0. Reset enadu 1 iddhu ಏನು ಮಾಡ್ತದೆ, b 0 ಮಾಡ್ತದೆ, 0 iddhu 1 ಮಾಡ್ತದೆ. That you just to take the declaring what the here the declare the variable reset ಬರ್ಕೋರಿ ಇದು. Declare the variable reset to that can hold the its value. That can hold its value. Okay, next is what the initialize reset to what the 1. It's what the initialize. We are doing what the initializing reset is to be what the initialize the reset to what the reset to what 1 ಆಗಿ ಇನಿಷಿಯಲೈಸ್ ಮಾಡ್ತಿದ್ವಿ. ಅದು ರಿಸೆಟ್ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ ಅದು. ಆಫ್ಟರ್ ದ 10 ಆಫ್ಟರ್ 100 times or 100 times or 100 milliseconds it can make it towards the reset to cost toward the 0 here, reset to cost the 0 here. Just to copy this figure, here's some ಏನ್ರಿ ಹಾಂ ಹಾಂ ಇಲ್ಲ ಇದೆ ಅವ್ನು ಹೇಳ್ತಾನೆ ಕರೆಕ್ಟ್ ಅವನು ಒಪ್ಪಬೇಕಲ್ಲ. ನಾ ಹೇಳಲ್ಲಪ್ಪ ಅವ್ನು ಮಾತಾಡ್ಸಲ್ಲ, ಅವ್ನು ಬೇಕು ಅವ್ರು ನಾ ಮಾತಾಡ್ತೀನಿ ಅಟ್ಟೆ, ಹೇಳಿದ್ರೆ ಮಾಡ್ತೀನಿ ಇಲ್ಲದ್ರಿಲ್ಲ ಅದ್ರಿಂದ ನಮ್ಗೇನು ಬರೋದು ಅಟ್ಟೆ. ನಾವು ಶಾಣ ಕೊಟ್ಟು ದುಡ್ದೇವು ಓದೆವು 11ದಾಗ ಕೊಡ್ತೀವಿ, ಬಟ್ ನಮಗೆ ಕೊಡಲ್ಲ ಅವರು. ಕೊಟ್ಟರೆ ನಾವು ಮಾಡ್ತೀವಿ, ಕೊಡಲ್ಲ ಅವರು. ಕೇಳಿದ್ರು ಮಾಡಿದ್ರೆ ಮಾಡ್ತೀನಿ, ಹೆಂಗೆ ಮಾಡೋದು? ಆಯ್ತು ಹೇಳು ಅವನಿಗೆ ಹೇಳು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಟೇಕ್ ದ ಹೆಡಿಂಗ್ ಆಸ್ ದಿ ವೆಕ್ಟರ್ಸ್. ಒಟ್ಟೆ ಓಕೆ, ವೆಕ್ಟರ್ಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಇಟ್ಸ್ ಮಲ್ಟಿಪಲ್ ವಿಡ್ತ್ ಮಲ್ಟಿಪಲ್ ಬ್ಯಾಂಡ್ ವಿಡ್ತ್. ಓಕೆ, ಮಲ್ಟಿಪಲ್ ವಿಡ್ತ್ ಅಂದರೆ ಏನಾಗುತ್ತಾ, ವೈರ್ನಾಗ ನಾವೇನು ಕಳಿಸ್ತೀವಿ, ಸಿಂಗಲ್ ಬಿಟ್ ಕಳಿಸ್ಬೇಕಾದ್ರೆ ಐದರ್ ವಿ ಕ್ಯಾನ್ ಸೆಂಡ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಸಿಂಗಲ್ ಡೈರೆಕ್ಟ್ಲಿ ಆಸ್ ದಿ 0 or 1 X or Z. Okay, something like this. If you want to send the multiple values, then we have to send in the form of array. That array we call as what the vectors. Okay, now take the heading as the vectors. Okay, vectors are the what the it's which are used to multiple. Okay, if you want to send the for in the data types. Okay, data types are what are those nets and the what the registers. If you are not declaring any okay values for them, default value is what the scalar itself. It's having the what the 1 bit of information. 1 bit of information carrying that type of data type. We can say it's for the scalar types. Those are what the scalar types. If you are sending the multiple bit of width, okay, if you are sending the multiple bit of width, means what the 0 to 3, means what the 4 bit of information that is to be sent through what the vectors. If you are not mentioning as the vectors as the 0 as the like 0 raised to 3 raised to 0, this is not, if you are not mentioning, that is wire are nets, that are, and even the registers that will take the default value as the scalar. That scalar is nothing but what the only 1 bit of information it will carry. If my data type is carrying only 1 bit of information, that definitely those type of data types we can say is for the scalar type. If you are mentioning the multiple bit of width of information where if you are sending those type of what the data types, we can say them as the vectors. Vectors always we having the default value as the what the scalar itself. Data types are having the 1 bit of information. If you are sending the multiple bit of widths, those to be what the considered as the vectors. There are two types ways we can send it: high to low, low to high. Means what the high means what the 3 raised to 0 ಕಳಿಸಬಹುದು, and even we can also send this for the 0 raised to 3 also. These are the some conditions are there. ನಾನು ಯಾವಾಗ ಈ ತರ ಕಳಿಸಬೇಕು, ಈಗ 3 raised to 0 ಯಾವಾಗ ಕಳಿಸಬೇಕು, 0 raised to 3 ಯಾವಾಗ ಕಳಿಸಬೇಕು, that we have the some condition over there. We'll see at that one in the next class. First, okay, there are two types are there. Okay, these are the vectors type. There are two types of vectors we can consider. One is what the vector part select, another one is what the variable vector part select. One is what the vector part select, another one is what the variable vector part. Okay, variable vector part selection. Okay, then we will see the, okay, let me write the some examples here. Wire, if you want to declare in the wire, okay, wire is defining what the 7 raised to 0. This is what the 8 bit of information, 8 bit. This is what the high, this is what the low. This is what the declare the 8 bits of wire. This is what the declaring. What we are declaring here, the wire. Wires are nothing but the nets. Are these registers? No, these are the nets. It will carry the information. How much it's what the declaring the, what we are declaring? Declaring what the net. Nets which are carrying what the, how many bits of information? Net bus which are having the what the, how many? 8 bits of information. ಈಗ ಒಂದ ವೈರ್ ಇತ್ತಂತ ಇಟ್ಕೊ, ಈಗ ನಾವು ಒಂದ ವೈರ್ ಇತ್ತಂದ್ರೆ ಏನಂತ ಇದಕ್ಕೆ ಒಂದು ಲೈನ್ ಇತ್ತಂತ ಇಟ್ಕೋರಿ, ಇದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ ರೀ, ವೈರ್ ಅಂತ ಕರಿತೀವಿ ಅಥವಾ ನೆಟ್ ಅಂತ ಕರಿತೀವಿ. ಅದೇ ಒಂದು ವೇಳೆ ನಾನು ಇಫ್ ಐ ಟೇಕ್ ದ ದಿಸ್ ಆಸ್ ದಿ ಮಲ್ಟಿಪಲ್ ನಂಬರ್ ಆಫ್ ವೈರ್ಸ್, ದಿಸ್ ಒನ್ ವಿ ಕಾಲ್ಸ್ ವಾಟ್ ದ bus. This one you call it bus. That's what one, that one only declaring, I mean. This is what the wire which is having the multiple bit of information. This will case what the declaring the net bus which are having the 8 bit of information. Similarly, even you can also define the wire. Another example, wire 3 raised to 0. 3 raised to 0. This is having the what the bus is what the bus is having the A, bus B, and what the, sorry, and barala, bus C. Okay, this is what the, there are three types of buses are there: bus A, bus B, bus C. These are these three types of buses which is having the carrying what the, each and every bus will carry the 4 bit of information. 4 bit of information. This bus width is what the 4 bit, means what the, here the how many wires are there in each and every bus? We have the 4 wires are there which are having the values as the 0 to 3 values. 0 to 3 means what the 4 wires are we using. Bus A is having what the 4 bit of information or 4 wires. Bus B is also having same. Bus C is also same. It means what the declaring the 3 buses which are having the what the 32 bit of 32 bit width. Okay, 32 bit width. Declaring what the, here the declaring what the, declaring what the 32 bit of width. this width of this bus, okay, this width of this bus is depends on what type of your processor we are using in our digital design system. That is to be declared. Usually nowadays the 32 bit or 64 bit use ಮಾಡ್ತಿದ್ದಾರೆ almost all ಎಲ್ಲ system ನಾಗು, but that's what we are having, the bus is having also what the 32 bit of width itself. And also here the V1, you can also define the registers also, registers. Okay, vectors, as I already told you that these are to be used what the declaring what the wires and the registers. ಈಗ ನಾವು wires ನೋಡಿದೀವಿ, ಇವಾಗ registers ನೋಡೋಣ. Registers are also having the 63:0. Okay, this registers is having the capability to what the storage. ಎಷ್ಟಿದೆ ಇದ್ರದ್ದು ಸ್ಟೋರೇಜ್? 64 bit. Okay, 64 bit. Even you can also define the registers as it is as 0 to 40. This is also having the size of what the 41 bit. ಈಗ ನಾನು ಆಲ್ವೇಸ್ 32 ಬಿಟ್ ಡಿಫೈನ್ ಮಾಡೋಕ್ಕಾಗುತ್ತಾ? ಆಲ್ವೇಸ್ 4 ಬಿಟ್ ಅಂತ ನಾನು ಡಿಕ್ಲೇರ್ ಮಾಡೋದಾ? ನೋ ನಾಟ್ ನೆಸೆಸರಿ 1. ಓಕೆ, ಹೌ ಮಚ್ ಇಫ್ ಯು ವಾಂಟ್ ದಟ್ ಮಚ್ ಯು ಕ್ಯಾನ್ ಡಿಕ್ಲೇರ್ ಹಿಯರ್. ಈಗ 0 to 60 it comes under what the 0 to 64 bit. This one here we can use what the width of minus, width of plus. That one will see what the vector part select. Another one is what the variable vector part selection. We will see in the next class. We will be explaining that one tomorrow. ಲೇಟಾಗಿ ಬಂದರೆ ಆಫ್ ಅಟೆಂಡೆನ್ಸ್, 2 days ಬಂದರೆ ಒಂದು ಆಫ್. ನಮಗೂ ಲೇಟಾಗಿ ಬಂದ್ರೆ ಅಂದ್ರೆ 3 ದಿನ ಲೇಟಾಗಿ ಬಂದು ಅಂತ ಕಾಲೇಜ್ಗೆ 1 ದಿನ ಸ್ಯಾಲ್ರಿ ತೆಕ್ಕೋತಾರೆ ಅವ್ರು. ಹಂಗೆ ನೀವು 3 days ಕಂಟಿನ್ಯೂಸ್ ಲೇಟಾಗಿ ಬಂದ್ರೆ ಅಂದ್ರೆ ನಿಮಗೂ ಒಂದು ಅಟೆಂಡೆನ್ಸ್ ಲೆಸ್ ಮಾಡೋದು. ಆಮೇಲೆ ಫೈನ್ ಅಮೌಂಟ್ ಹಾಕ್ತಾರೆ. ಫೈನ್ ಅಮೌಂಟ್ ನನಗೆ ಹಾಕ್ಲಾಕ ಕೊಟ್ಟಿದ್ದು, ನನಗೆ ಕೊಟ್ಟರಂದ್ರೆ ನಾನಂತ ನಿಮ್ಗೆ ಬಿಡೋಲ್ಲ, ಶನಿ ಕಾಡ್ದಂಗೆ ಕಾಡ್ತೀನಿ, ನಿಮಗೆ ನಿದ್ದೆ ಮಾಡೋಕ್ಕೂ ಬಿಡೋಲ್ಲ.